To increase API performance, you must reduce network latency, optimize database interactions, and minimize data payload sizes. Implementing these strategies can cut response times in half and drastically improve throughput. The most effective architectural and programmatic strategies to optimize your API include: 1. Implement effective caching. Database queries are often the largest bottleneck. Storing frequently accessed, slowly changing data in memory eliminates repetitive backend computation. 1. Application caching. Use in-memory data stores like Redis or Memcache to serve read-heavy queries instantly. 2. HTTP caching. Use and headers so clients and proxies know when they can reuse local copies of data. And 3. Edge caching. Deploy a content delivery network, CDN, like Cloudflare to cache static or semi-dynamic responses physically closer to global users. 2. Optimize database operations. An API is only as fast as its underlying database. 1. Indexing. Add strategic indexes to columns used in, and clauses. 2. Connection pooling. Reuse existing database connections via a connection pool to avoid the expensive CPU overhead of opening and closing connections for every API call. 3. Solve N+1 problems. Ensure your Object Relational Mapper, ORM, utilizes eager loading instead of lazy loading to fetch related data in a single query. And 4. Read replicas. Route heavy read traffic to database replicas, leaving the primary database dedicated to write traffic. 3. Reduce payload size. Transferring unnecessary bytes over the wire slows down transmission times. 1. GZIP, Brotli compression. Enable compression on your server, e.g., Nginx or Apache, to shrink JSON payloads before sending them over the network. 2. Data trimming. Modify endpoints to return only the fields the client actually needs. Avoid returning entire database rows by default. And 3. Efficient pagination. Use keyset pagination, cursor-based, instead of high offset pagination to stream large datasets in smaller, manageable chunks. 4. Offload to asynchronous processing. Do not force users to wait synchronously for tasks that do not impact the immediate HTTP response. 1. Background workers. Move time-intensive tasks like sending emails, processing images, or generating PDFs to a background worker queue. 2. Message brokers. Use tools like RabbitMQ or Apache Kafka to ingest heavy data spikes quickly and process them asynchronously. And 3. Asynchronous logging. Write system logs to a non-blocking memory buffer that flushes to disk periodically, rather than executing a blocking disk I/O operation on every single API call. 5. Optimize network and infrastructure. Proper traffic and server management keep your environment resilient under heavy load. 1. HTTP, 2 or HTTP, 3. Use modern protocols to allow multiplexing, allowing multiple requests to travel concurrently over a single TCP connection. 2. Load balancing. Use a load balancer to distribute incoming traffic evenly across a cluster of server instances. And 3. Rate limiting. Implement throttling via an API gateway to prevent malicious actors or poorly coded loops from overwhelming your servers.